Thanks, John. Welcome, everybody. Today's webinar is just going to be the new product from SOLIDWORKS, SOLIDWORKS Inspection. So I'm just going to do a brief overview of inspection today. This is obviously you're dialing into your interest in this product, but if you do want to follow up after this webinar in terms of a more detailed demonstration, then just call your account manager to arrange that sort of thing. So we'll get into the presentation. I'll just run a few slides first of all, just explain what SOLIDWORKS Inspection is. So it's a product to automate the ballooning of engineering drawings to minimise the time needed to record inspection measurements, and so it streamlines the whole process basically and performs to industry standards. So hopefully I'm going to show you today that there are going to be some massive time savings. We can eliminate errors and inconsistencies, and it should be a really quick return on investment in terms of the initial outlay and then the money you're going to claw back in time more than anything. So inspection creates documentation for quality control and quality planning. So inspection documentation or first article inspection reports. We're going to show you some balloon drawings and how we do that. And SOLIDWORKS Inspection works to any of the sort of major can't think of the word. Let me go back. I think it's on there. Standards. That's it. That was the easy word to remember. So that's what we're going to show you, hopefully, and it's going to perform in sort of any area of the business, any stage of the process. So in process, final, or incoming parts into the business. So the main capabilities, I'll sum up these fairly quickly. We'll sort of sum them up as we go along as well. But it's going to be up to 90% faster. So maybe not 90%, maybe 50%, maybe 60%, I don't know, but up to 90% faster. It's all automated, as you'll see soon, and then it's easy to use, so little or no training required. So I think there's probably a little element of training required, but it's it's probably an hour at the most. So SOLIDWORKS Inspection should meet all your inspection document needs regardless of your CAD vendor. So it's a standalone application, or it can be a standalone application. It's also fully integrated within SOLIDWORKS. So you can use it on your SOLIDWORKS drawings, but also you can use it on things like PDFs or TIFF files. So it doesn't have to be even a drawing from SOLIDWORKS or a 3D CAD system. It could be a PDF from AutoCAD even, or something like that. So we've got real good tools in there to recognise information from PDFs and TIFF files. So hopefully it's going to reduce delivery time for you. That's the main benefit, increase or decrease time to market, eliminate errors and consistencies, like I said already, create inspection packages and reports in just a click when we've set all the stuff up, comply with industry standards, and we can publish XML files for integration with other quality systems as well. And that's probably a more in-depth discussion than today, but just to let you know, it can be done. So we can type in measured values directly into the software to have a comparison against the dimension and tolerancing. We can use digital calipers or other digital measurement tools that plug into the computer to obtain those numbers without having to type them in manually. And we can also import things from CMM machines as well. So anything that's been recorded from there can be imported directly into the software. And we've got a big range of machine manufacturers that we work with that can help with that. And you can write your own sort of templates to work with anything that's perhaps custom as well. And it highlights a dimension and characteristics based on the results from that as well. So just before we get started into the demonstration, there's two packages for SOLIDWORKS Inspection. SOLIDWORKS Inspection Standard and SOLIDWORKS Inspection Professional. So the top 6 bullet points all get included in Standard, and then the 4 additional bullet points get included with the 6 bullet points above in Professional, so you get all 10 in Professional, of course. So the main differences are the automated measuring towards sort of the end of the demonstration. So a lot of the start of the demonstration being Standard, and then when I sort of switch over, I'll tell you when that is and when we're going into Professional. So these are the sort of 3 key areas we're going to look at. We're going to look at creating an inspection drawing from a PDF or from a SOLIDWORKS model, or SOLIDWORKS drawings file, sorry. They'll only look at creating inspection reports, so these are all based on templates, and I'll show you how to edit those very quickly. And then we'll go on to the sort of the professional sort of side of things, where we're entering measured values into the software rather than just into an Excel sheet. So we'll just jump into SOLIDWORKS Inspection first of all. So this is what it looks like. I'll just start a brand new project. We've got lots of different templates for the projects that we can employ. I've only got a couple in there currently, but if you want to work to a certain measurement type, imperial or metric, or if you've got some tolerances set up, we can have them all set up in these templates, so it's not a start from fresh each time, just as it is with SOLIDWORKS templates really. So I'm going to go with this AS9102 template. And then I just need to find a file. So I'm going to start with a standalone version of inspection first of all, so just a PDF file. So this lower plate PDF. So I'll just open up in inspection, and we can see the interface a little clearer now. So this is fairly similar to most Microsoft products nowadays. So across the top we've got this tabulated toolbar, as you get with most things, the Microsoft ribbon. Down the left hand side we've got some project characteristics we're going to capture in a second. We've got some CMM data import tools we'll look at later on. That's in the professional package. And then down the bottom we've got this bill of characteristics. So the things we capture get listed down the bottom, and you'll see them sort of appear as we go along. So this is just a PDF file, so you'd navigate around this as you'd expect to, and there's some sort of view tools in inspection to zoom to area or zoom to fit and that sort of thing. So we're going to capture some things from this drawing border down the bottom. In SOLIDWORKS, when we get there, we can just import these directly from excuse me, directly from the file properties, but on a PDF, of course, we've got none of that information. So if we want to capture the part name, we're going to use this little button here that takes us into the optical character recognition tool that inspection uses behind the scenes. So before we go into that, we can customize that slightly. So obviously some drawings have got different types of text on. In SOLIDWORKS it's no problem, but on a PDF, unless we've got searchable text, we need to actually take a picture of this almost and try and regurgitate this in code rather than as a picture. So in the options we've got some options in there to sort of specify things like the font type we're using, or if we have got searchable text in these PDFs and things. So this one's Century Gothic font that we're using, so that will extract more of the information more accurately if we use that. So we can just turn that on or set that up. Obviously, if you're using your own drawings, it's all going to be fairly standard. You're not going to have to mess with that too much. So first thing we'll do is extract the part name. So we just click the little box, draw a box around the part name, and it extracts that information and puts it in as text into this box on the left. Same sort of thing with the part number. Because this is optical character recognition, you have just got to be aware that it might get it wrong. With standard letters and numbers, it's going to be fine. With other things, maybe it's going to get things slightly wrong, perhaps. But it's just bear in mind that really when you're doing this, so you can check things. So we'll just get the revision of this drawing as well, and that gets populated into there. So if there's any other things, we can just populate them into these boxes. Otherwise, we can just press the OK, and that's sort of done that. So we'll just go for a zoom to fit now. Perhaps zoom in a little bit further actually, just so we can see this a bit easier for capturing the rest of the information. So now I want to capture some characteristics. I'm just going to dock that on the sides. So we're going to start capturing things like notes and dimensions and perhaps geometric tolerances. So we'll start off with these notes at the top, and it's the same sort of process that we've just been through really. Because we're not capturing properties, we've got to sort of tell it what we're going to capture. So we're either going to capture a dimension, a surface finish, a weld, a geometric tolerance, or a note, or something else. So we'll just hit this note button, and then, just as we did before, drag a box around this note. It'll take a picture of that, scan it, and turn it into text in the box down here. So that's note 1. There's a couple of other notes we want to also capture. So that one there, and that one there. So that takes those 3 notes and drops those into the bill of characteristics, so it's all itemized in there now. So we want to do some dimensions also, so we can click on the dimension capture toolbar up here, and just again drag a box around a dimension. So this dimension and most of these dimensions on here have got tolerances. So inspection is going to look at the value and also look at the tolerance as well. So it looks like just checking that quickly. The value's not come through for whatever reason, so we'll just go and recapture that. Just have another go, and it's got it that time. So just like I say, just bear in mind that it might not capture it correctly every single time, but it's going to get it right most times. So it's picked up the value there, and also picked up the upper and lower tolerance. So it's worked out from that an upper and lower limit. So it's going to do this for all dimensions we capture. So if we just capture some more dimensions, so just grab this one here. That one's going fine. This one, and as we're doing this, it's going to balloon them up, and all the balloons and things can be customized to be whatever sort of spec we want, whether we want them filled in red or just a red outline with a red number, or square or circular or diamond shape, whatever type of balloons you use currently, then that's not a problem to replicate that. So I'm just going to get this radius note here. There's two of these radii, so it picks up that sort of thing as well. It picks up this 2 in quantity. This is the value. The tolerance, there isn't a tolerance on there currently, so it's using sort of a default tolerance that's in the options of this project. So I'll just jump over to the options of this project now, and in there we should be able to find a general. There we go. For any linear or angular dimension, we can either, without a tolerance, we can either specify a tolerance by precision or by a range. So 0 to 100 mil has got this tolerance, 100 to 1,000 or 10,000 mil has got this tolerance. So we'll go with a precision version. So anything to 3 decimal places is going to have a 0.005 plus or minus tolerance on there. So that's where it's got that information from in the event that there's no information on the drawing or on the dimension anyway. So we'll just carry on going around and picking out some of the dimensions. So just grab that dimension there, just each time just making sure that it's gone into the left-hand side as you'd expect it to be. So on this one we've got a plus and a minus separately, and it's picked that up just fine on the left-hand side. And this one here is a limit, it's upper and lower limit, so it just picks out the value and also puts the upper and lower limit in, so when we come to inspecting this we know the upper and lower limit. So that's all of the dimensions captured that we want to capture. At the bottom here we've got this bill of characteristics that captures all the notes and dimensions that we've looked at, and the upper and lower limits, and we can start specifying things per dimension now. So perhaps for this overall dimension that we're on, maybe our inspection method is going to be digital calipers. So we can start specifying how different dimensions should be measured if you want to as well. So that's an option per dimension, or we can do that sort of overall. We can move these around, these balloons, so currently they're in the order we picked them, but if we wanted number 11 to be further up somewhere and replace that with number 8, it sort of just reorders all the balloons and puts number 8 at the end. So we just skip 8 out until we get to the end, so we can reorder them just as you'd expect to be able to do. Balloon number 9 here, where it is there's 2 in quantity, maybe that needs to be 2 separate lines in the bill of characteristics. So because there's 2 versions or 2 radii, one could be incorrect and one could be correct, so we need to sort of differentiate between those. So we just select item 9 out of this list. We can either select it from the list here or from the modeling area or the PDF over here. And there's just a small button on the side here to create an instance for each item. So we'll end up just with a 9.1 and a 9.2. So we can group and degroup those as much as we like, really, but that gives us then a separate dimension to check against when we get to exporting any Excel information with the actual dimensions on there. So we're pretty happy with that PDF now. So what we may want to also do is, if we've got a number of PDFs that we're building up, we may want to import a sort of bill of materials as well. So along with a report for this drawing, we want a report for every drawing and a report at bill of materials level. So we can import a bill of materials. We can do that from a CSV file or Excel file, something like that, so you can export your bill of materials directly from SOLIDWORKS into here. Otherwise, maybe you need to do that from a PDF because you don't have the CAD model. So we can just add an additional drawing. So we've got a parts list PDF here we can add. Just got a list of parts on there. and we can capture this in a similar sort of way. So rather than importing from a CSV, we can just extract from there. So just use the extract, box select the whole table. That will then sort of itemize this in a table over on the left-hand side. All the headings currently are unassigned, so we can start assigning those. So this one where there's a dash, we don't want to assign that with anything, that's not really important. But the description is, so we can assign that with a description. If we had a description, we'll call that part name in fact. The number here, that could be a serial number, and here could be a part number. So when we're happy with how this is laid out, and we can reorder based on part number, serial number, or name, something like that, we can OK that, and that will just give us a bill of materials now that will come through on any documentation we export later on, so it can itemize the whole range of parts and then have an inspection sheet for each one. So if this was quite a busy drawing, this is obviously quite a simple drawing. When you're going around capturing information, it might be difficult to see what you have and haven't captured. So we've got some nice little tools in here to hide away things. So when the balloons at the side of each dimension is getting or covering up another dimension or another bit of information, we can just hide all the captured information. We can turn the balloons off and things, and then we can clean up the drawing and see exactly what we haven't captured very easily without having to sort of look around and see what we haven't captured. So it's just a show hide button really, just to delete all the information we've already captured. So that's great if we're working on a drawing that doesn't change revision, but inevitably the drawings that we're working on are going to change revision. Something's going to change at the part level or assembly level, which can have a knock-on effect to the parts. And then we need to sort of re-balloon, or at least find out what the differences are, so we can have an intelligent way of re-ballooning. We don't want to just start again, because that's not practical. There might only be one change or one dimension added. So we've got some nice tools in Inspection to do that. We can use this replace drawing feature. So we can just tell it to compare with a later version. So we're working on A2 revision currently. We're going to move that to D2. So we'll open that file. It's just going to give us a little message just asking if we want to compare the drawings before we replace them. So we'll compare that. It's quite a clever thing. It puts one drawing in red, one drawing in green, and overlays the two. So basically anything that's in an identical place to what it was before is in black. Anything that is brand new is in green, so these two angular dimensions are in green, they're brand new. Anything that's no longer on the drawing is now in red, and anything that's perhaps moved or modified or moved locations has sort of got this overlay. So from that, it's without having to look through every single dimension, you can see that there's two new dimensions. There's one that's been modified and there's one that's been deleted. So we can make an informed choice now on how we re-balloon this, so we don't have to re-balloon anything from 1 to 9, apart from 8. We can take the last 3 balloons off perhaps and then re-balloon those separately. So it's just giving you a better indication really what you need to do in terms of getting this up to the latest revision. To help with that also, if you've got a large drawing or just a large amount of dimensions, being able to identify where the dimension is in terms of a grid reference, we can insert a grid onto the drawing. So some drawing borders have grids on already, so this will just complement that. If it hasn't, then it's not lost. We can still use this just in Inspection, but we can apply a grid to this drawing, which will give you just an overlay of a grid and some grid references. If we're trying to match an existing drawing, we can use these tools down the bottom on the left-hand side here to specify how many rows or columns we want, whether it's the alpha or numerical. We can change that around. We can specify which way the numbers go, so we start at D1 through to D5 and C, B and A up the top. And we can hide and show these sorts of things. So there's just a hide show toggle on the side here, and we can apply that to all drawings or just a single drawing. So the little tick box here just applies it to a single drawing. Or maybe you only want to apply it to an area of a drawing, so there's an option for that as well if you just want to do that. We can change the colours of the grid references and grid lines and things. But if we just OK that, each item that's been ballooned in this drawing now will get dropped into one of these grid references. So we can see that item 3 up the top here is in A1. So the character zone is A1, and all of these parts have got the character zones in there. So when it comes to looking at where the dimensions are, perhaps this can be exported to an Excel file, you see. So you can very quickly identify on a drawing where that balloon is if there's hundreds of balloons, for example. So when we've got to this stage and we've ballooned everything up, we've put the grid on there. If we want it, we can hide show that when we export this as PDF, but we can now just export this to a PDF. So we've got the original PDF that we've then put some annotations on top of and extracted some information out. We can save that as a PDF. It'll just suffix this with a suffix, in this case ballooned, but it could be anything you want. That's all customizable. It's just doing 2 sheets, so we didn't need that second sheet really, but this first sheet is the ballooned version of our drawing. So along with that ballooned version of the drawing, we want to export some other things. So one of the other things we may want to export is an XML file. So if you've got other systems currently, that quality systems that you want to interact with, that's where the XML file would come in. And so we're not going to go into great detail with that today, but if you do want to know more about that, that's something we can talk about. So just before I go any further, I'll just jump back into the PowerPoint. So we've looked at the inspection drawings. So we defined the project, captured the characteristics, assigned some inspection methods perhaps, and then published the drawing. And the benefits in that was to eliminate manual ballooning. So it's a very automated process. We're going to save time, and it clarifies the inspection procedure, hopefully. So that's just the drawing side of things. Then we've got to look at the inspection report side of things, so what goes along with that drawing. So we're going to publish an Excel report in a second. We're going to use a template to do that, and we'll look into the template and how easy that is to change. And in that template we can create multiple sheets on an Excel for multiple parts, or maybe one sheet is for the part, one sheet's for the assembly, one sheet's for the material specifications and things. So we'll just jump back into inspection. While we're still here, we'll export to Excel, so it's just the Excel link up the top. We're going to use a template, so I've got a number of templates in here, and you can create as many more templates as you want with this as well. So we'll just use this AS9102 template, hit the export, and off it goes and pushes out an Excel file. So this itemizes all the characters, or all the numbers based on the balloons we've got on the drawing. It gives you a type of dimension, so linear, radial, or note perhaps, any notes or the actual dimension, so the requirement, what units is in, an upper and lower limit based on the stuff we selected, and then we've got results page now. So in here now, if we've got this report in Excel, we can measure the part and then start typing results. So the first one's 0.35, and that stays in red because it's a fail. The second one comes in at 0.6, and that's green because it's a pass. The next one's 0.68, that's also green. So we can go down here and start adding in the values we measured off and very quickly see the results, pass, fail, that sort of thing. So this is all included in the inspection standard module. So to modify one of these, actually I'll go through a little bit more on this. We've got a multiple sheet, as I mentioned earlier. So form 1 itemizes the bill of materials we extracted, part numbers, lower plates, whatever we've extracted, whether we can get it to import into any part of this Excel sheet. And then form 2 in this case is the raw material product accountability page as well. So again, it's only got 3 sheets. You can have more or less. You can create exactly exactly the documentation you need to create. So to modify one of these bits of documentation, let's go into the options and look at exporting. And just down the bottom here, we've got this Excel list, or Excel list of templates. So we're going to find the template we've just used there, and if we click on this, we can go into the sort of the template editor. So it pushes into Excel with the template we've selected, and on the right hand side we get this SOLIDWORKS Inspection template editor. We can start adding extra things from this. So this links it all back to inspection without you having to know all of this sort of the code that goes behind the scenes. So I'm going to just add a new column into here now. So if we insert a new column, we'll call this zone. And the first thing we don't have to do this for every single cell, we'll just do it in the first cell, but we're looking for a characteristic token of zones, and that should be in here somewhere. Right at the bottom. So we click on Insert, it inserts the code that's required to input that into the Excel document. So the template's now updated, so we can finish this template, we can save it as something else, so we'll call it this AS9102 plus zone, we'll overwrite that one. So just replace that one. Okay, that, and if I do exactly the same process now and export this as Excel, use the plus zone option, hit the export. I'm just going to overwrite the existing one we just did a second ago, but it will push that out into Excel. And now we've got a zone characteristic in there as well. What we could also do in the template is specify different font styles. So I've got some odd fonts coming through there for some reason, so we'll just go with a standard Arial font. I can see that's exactly as we expected it to be. So we'll just jump back to the presentation. So getting that inspection reporting side of things, we can adhere to standards because we've got templates set up to do that. We can eliminate errors, especially as long as the drawing's correct, of course, and there's no errors on the scanning of the optical character recognition, and we can save time by doing that. So I'm not going to type all that out and work out the upper and lower limits manually. So that's more or less everything that's included in SOLIDWORKS standard. SOLIDWORKS inspection standard. So we'll just move on to the inspection professional, which is going to give us this extra functionality to it, enter measured values directly into the software rather than doing it on an Excel sheet afterwards. So we can type directly into the software. We can do, well, we saw some conditional formatting anyway, making the things go red or green based on whether they pass or fail in Excel, but that's going to happen in the software and Excel now. We can color code characteristics on the drawing, so highlight the dimensions on the drawing red, green, or amber, depending on the type of pass, fail, or marginal pass. And we can import from digital calipers, the digital equipment, or CMM. So we'll jump back into inspection, and we're going to, on the right hand side, we've got this measurement input. So if you don't have inspection professional, you wouldn't get this extra little tab here, but all you have to do in here is, based on each line item, we can manually insert things. So we can say that's a pass, that note. I'll just say that just save our project. So that's a pass, this one's a fail, it doesn't conform to that one's a pass, and then we start getting onto the dimensions. So that was 0.6 perhaps, that's a fail, that's 0.6, that's a marginal pass, and this is a 0.68, and that's a pass. So we're typing those in manually. This could also be inputted, the dimensions I'm inputting there could also be inputted from digital calipers, so it doesn't have to be a manual input at that stage. So that all looks okay, and we've got some green, red, and yellow highlights on there. So where it gets that information from is into the measurements input. So you're going to get 4 different colours in your PDF behind this window. So you're going to get grey, which is unspecified, so we're not putting any values in there. We're going to get green for a pass, yellow for a marginal pass, and red for a failure. And we can specify exactly how much, how close is a marginal pass and that sort of thing in there. So that's just one set of results we've inputted there, but we can also add additional columns and input results for multiple tests. So we can add a column in here, and then on this test we had a pass, and we had another pass again. Then our values is at 0.32, 0.62, and 0.67. So on the test number 2 or inspection number 2, everything's passed that we've inputted. On inspection number 1, there's a couple of things failed and something that was quite close. So if you got a small sample out of a batch, we can see across that sample sort of a history of, or maybe this is over time, maybe over a period of weeks or months, we can test that things are either deteriorating or getting better based on machine tool wear and that sort of thing. So we can keep a track of all that. because we've now inputted this into inspection rather than just onto an Excel sheet, we can then start publishing this straight to Excel with all the values already in there. So if we export this out to Excel, we'll just pick a different template. This one here has got all the cells in there for things that have already been inputted, like these dimensions down here. So we just need to export that. Off it goes and pushes that out as an Excel file, and we've got all the correct annotations in there now. So we've got all the stuff we had before, but also under the results we've got whether it's passed, failed, whether it's a marginal pass, and we've got the separate colours on there to represent that as well. So, so another option for inputting data is inputting it from CMM. So to do that, on the right hand side we've got this CMM import we can do. So we'll just look at the settings first of all, I think. So these are the list of CMM machines that we're going to talk directly to without any customization. So you've got all the major players in there, but if there's anything that's they're not in that list, we can write sort of the rules behind the scenes to make it work for the output that you get. So if it's not in that list, it's not the end of the world, it's just a little bit more work initially. Of course you only have to do it once, but just to get a little bit more work initially to get things working. So to import things from CMM, I'll just pin this back. We just need to add a file, so we need to browse for a file and pick either one file or multiple files. So we'll go and browse for, we've got these 3 files here, so 3 outputs. We could have 20 outputs if we've measured a batch of 20, so we can do this all in one hit. We'll open that and it'll bring all the information into inspection. Now if the when the CMM was set up, if all the annotations and dimension numbers were relayed over to the CMM, then they would just match through exactly. So that would be great. That would just work straight away. We could auto-assign all the item numbers and it would just work. Now, I don't know how often that's the case, so if that's not the case, we can do some other things. We can manually assign things, so say this is balloon 4, this is balloon 5, and go through manually. Of course, we'd rather not do that. The alternative to that, I guess the way we could do it to get 95% or maybe even 100% of the things assigned is by assigning things by type. So it's only going to assign a linear dimension to a linear dimension, and only if the nominal values match exactly, and only if the plus or minus tolerances match exactly. So unless you've got 2 dimensions of exactly the same on the drawing, then you're probably going to be alright with this method. Obviously the ideal is to get the item number correct first time, but that's not always the case. So if we tick these 4 boxes, we're looking for exact matches, not best matches. That's sort of defeats the object a little bit. So we hit the OK, and it's just going to assign all of the dimensions from the CMM into the drawing and find the matches. So anything that's been matched has been imported, so everything looks like it's passed based on the dimensions we've got back. We've had 3 tests, so they're the 3 columns, and these are the dimensions that have been tested against. So we can see again that they're highlighted in the PDF as green. So if you're testing a batch of 50 parts, for example, then that's obviously based with the CMM. We can get all that information in very quickly. You only have to assign the things once if it's not assigned up correctly, but you're going to do all 50 tests all in one hit. And we can export again an Excel of this with that same template, which will push this out into Excel and give us the range of values that have been measured and whether they conform to the correct tolerances or not. So that's just what you get extra in the professional version. So I'll just jump back into the PowerPoint. So the benefits of entering those measured values directly either into the software with calipers or with CMM, it automatically identifies a pass and fail. We've not got to really think about it. And we can monitor quality over time by having that option to have multiple tests all in there all at once. So that's the sort of general overview, I guess, of inspection. That's a standalone version. I'm going to very quickly run through the SOLIDWORKS add-in. A lot of the functionality is all identical, apart from just the user interface more than anything, and the ability to be able to do things much quicker because the actual text is inside the drawing. So I'll just jump into the add-in, the SolidWorks add-in, and do that, and then I'll just come back and summarize. So if I just find SolidWorks out, so this is that same drawing in SolidWorks now. The add-in, as you'd expect it to be, is in the add-ins, so just tick on the SolidWorks Inspection add-in there, and we get a new toolbar, the SolidWorks Inspection toolbar. So there's a few buttons on here, we won't really go through much of this, but we're going to start a new project, basically. So we'll start a new project there, and that automatically creates a new project, and then we can start looking at mapping the properties, just the same as we did before, but now we've got the SolidWorks drawing, so we can probably do this a lot more intelligently. So if we click on the part number there, it's going to take us to the custom properties, so I can just pick out the part number, and that drops it in. We pick out the part name, that drops it in there. We'll pick out the revision, and that drops it in there. So we don't have to scan any part of the page to try and get that. We can then start setting up things like what number do you want the balloons to start at, when it auto balloons, do you want them to go clockwise, anti-clockwise, or just completely random. We can look at the classification of the dimensions. We can create an instance for each, create a characteristic for each instance, like with the radius dimension we did earlier. We can auto balloon this can do it all automatically. And we can also get into the sort of sampling. What's the lot size? What level of sampling do we want? What type of sampling do we want? What is the percentage acceptable defect rate, that sort of thing. So when we've set all that up, we can just go into the next tab, and this is where it's very much more automated than it would be in the standalone version. So as a designer, when you're designing things, we could design things and mark some dimensions for inspection. So what you'd do in that case is the quality inspector would come along, tick the inspection only dimensions, and it would just pick up on all the inspection dimensions. Now, if the designers haven't done that, then obviously that's the case of going around and doing it manually. So if there's a lot of dimensions that need doing and inspecting, and not a lot that don't, then you're probably best off to include all and then delete the ones you don't want. Alternatively, you can just go around and do it manually, very similar to what I did in the standalone package. So in this case, we're going to go to include all of the dimensions, include all notes. This is the extraction criteria, so for things like radius, if it's got 2 times in front of it, it's going to pick out 2 quantity. If the notes haven't got a 1, 2, or 3 in front of them, it's not going to call that out as a note, that sort of thing. So that's all the sort of information in there. It looks fairly complicated, but there's a help file that can guide you through all that. And then we can pick up whether we want to do geometric tolerances, hole call-outs, welds, surface finishes. So we'll just include everything on this one. Hit the next icon, and then we can specify now, just as we did before, if the dimension doesn't have a tolerance, what tolerance we're going to apply on that. So we'll do it by precision, range, or you can just use the document defaults from SolidWorks. So that would mean you wouldn't have to do any of this sort of thing, just straight on document defaults. We'll go with precision on this in this case, and again we've got angular or linear, so up to 4 decimal places. When we're happy with all that, we can just hit the OK. So what inspection is now going to do is look at the drawing and start ballooning notes, dimensions, geometric tolerances up on a number of pages. So it's done it all automatically. And it's given us a list, a characteristic tree, similar to the one down the bottom in the standalone version. So there's a couple of things we might want to change about this looking through it. Maybe we don't want to inspect the fact that there's a note header, so we can right-click on that and untick the select for inspection. So that's not now in the list of things to inspect. If there's any other dimensions we want to either include or not include, we can click on them here. We can click on them over in the drawing, and we can just tick whether it's selected or not. This is all the information really for the balloon. So what type of dimension it is, whether it's a key dimension, we can tick it's a key dimension. It'll go and re-balloon everything, and the key dimension in this case is just a different shaped balloon, but it could have a prefix of K or something like that. If we want to remove a balloon, so we don't want to this geometric tolerance 4, we don't want to include that, so we can untick that, and off it'll go and re-balloon. So we don't have an item well, we do have an item 4, but it's not that geometric tolerance now, it's turned to something else, so we just have one less item in the whole thing. So that's very similar to what we did before. Now, in terms of revisions now, it's probably a little bit easier than it was previously, because we've got all the information, all the balloons in the drawing, and these are actually saved in the drawing file as well, so it's not an external file, it is the drawing file that they're saved in. So if you do want to turn these things on and off, you'd probably use the layer property dialog box, so it just creates a new balloons layer in there, so we can hide and show those quite easily, or maybe we want to change the colour of those, we can do that very easily as well. But if you want to modify this drawing, so we're going to up revision this, and we're going to add an extra dimension on or something slightly changed, we can just dimension something up. So I'll just dimension the length of this slot up, for example. That's now an additional dimension, so we can go ahead and see that in this tree when we click the refresh button. So if it goes and balloons everything up for us, that's in the tree now, but it's sort of automatically hidden. Or well, actually, it shows us that it's automatically hidden from it's not got a balloon, but it also shows anything that's new in green, anything that's been removed in red, and sort of gives you a good clear view of that. So we can click on there and just say that is now an inspection dimension, and that will just add a balloon on. So it's doing this all automatically for you. So when we're at that stage, that's when we can start publishing a PDF out. So it's just a normal file save in SOLIDWORKS. So file save, change your file extension to PDF, hit the OK, pick the number of sheets you want to export, and off you go with the export. All of the rest of the functionality, all of the Excel exports is still available. It's just a nicer side when we're itemizing the drawing, really, in the add-in, if you've got the SOLIDWORKS drawing. If not, obviously you just have to use the standalone version. So I'll just jump back into the PowerPoint. So we've been through these three key areas: the inspection drawings and creating those, the reports that go along with them, and then in the professional version of inspection, entering the measured values into the software rather than the Excel sheet. So with that, if there's any questions, obviously you can. You've been perhaps asking John along the way. If there's something a little bit more in depth that you want to ask questions about, then it's just the sort of normal route you'd ask any questions about SOLIDWORKS. So just through to the support desk. If you want to speak to me directly, you can call just at the main line and ask for me, David Newis, and we'll talk to you about any concerns or any questions you've got on SOLIDWORKS Inspection. But thank you for listening. Hopefully you found that useful, and like I said right at the beginning, if there's any real interest in this and it's something you want to look at further, then the best way is probably to contact your account manager, arrange a demo, or arrange for us to come in and have a look through your processes and see if we can help any further. So thank you very much, and have a good weekend. Thanks.